This is the last formula for area that you're going to learn. It's area of regular polygons. If you remember, a regular polygon has all sides congruent and all angles congruent. So if you think of a square, it has 4 right angles, so all the angles are congruent. They're all 90 degrees, and all the sides are the same length, so they're all congruent. There's a new vocab word that we're going to use in this formula. It's called the apothem. The apothem is the shortest distance from the center to the side. So don't get confused by this circle here. And don't get confused by this word radius. We're not going to actually use that. So if we use this square that I drew up here, and we drew in the apothem goes from the center to the side of the polygon. And the apothem always forms a right angle with the side. So every figure, even if I drew a triangle, has an apothem. So I'm going to draw this, I'm not going to draw it straight down, I'm going to draw it to one of the other sides, from the center to the side, and it forms a right angle. So that's what the apothem is. The formula that we're going to use is the area of a regular polygon is half the product. Remember, product means to multiply. So half the product of the apothem and the perimeter. So it looks like this. Area equals 1/2 apothem times perimeter. So the lowercase a is the apothem, because our uppercase A this whole time has been area, and our capital P is perimeter. And remember, to find perimeter, we add all sides, but we'll have a nice shortcut that we'll use. Let me adjust this. There we go, not twice. So we'll have a nice shortcut that we'll use for some of our figures to kind of make that perimeter a little bit easier to find. So this first problem, find the area of a regular decagon with a 12.3-inch apothem and 8-inch sides. So if I use the formula, area equals 1/2 apothem times perimeter, I know that the apothem is 12.3. So area equals 1/2 times 12.3. And then times the perimeter, I need to add up all these sides. So 8 plus 8 plus 8 plus 8 plus 8. But because every side is going to be the same, and there are 10 of them, I can say that the perimeter is 8 times 10, or 80. So I can put 80 in for the perimeter. So now, just like we did with rhombus, kite, trapezoid, and triangle, I'm going to start from the right and move to the left and do 80 times 12.3. I get 984. I want half of that, so I'm going to divide by 2. And our area is 492 inches squared. So the next one says, find the exact area of a regular hexagon with one side that is 10 millimeters and an apothem that is 5√3 millimeters. So using the formula, area equals 1/2 apothem times perimeter. 1/2 will stay the same. Well, we're told our apothem is 5√3. We had a similar problem like this. I think it was with trapezoids, where we had a root 3. And then when we find the perimeter, we know that one side is 10 millimeters and then that we have a hexagon. And so you have to go back and know your vocab for your polygons and know that a hexagon has 6 sides. So we're going to take 6 times 10 to get a perimeter of 60. So we're putting that 60 in here for perimeter. So area equals, first we're going to take 60 times 5. I'm going to leave the root 3 alone for right now. 60 times 5 to get 300. I want half of that, so I'm going to divide by 2 to get 150. That root 3 we haven't touched yet. It's coming down to be part of the answer. 150 root 3. And our units is millimeters, so millimeters squared for our area. So then we have, move this and clear it up for you guys. There we go. Find the area of a regular triangle with one side that is 6 centimeters and an apothem of √3 centimeters. So again, we don't have to have a picture for this. So area equals 1/2 apothem times perimeter. Our apothem is just that √3. And our perimeter, the side length is 6, and we have a triangle. So a triangle is 3 sides, so 6 times 3. So our perimeter is 18. Again, I'm going to save that √3 for my answer, and there's no number in front of it, so really I'm just taking half of 18. So 9, bring down the √3, 9√3 centimeters squared. The last problem in the notes, find the area of this regular polygon. So we have area equals 1/2 apothem times perimeter. So 1/2, our apothem is 6. Our perimeter, our side length is 5. And we have 1, 2, 3, 4, 5, 6, 7, 8 sides. It didn't tell us what kind of figure we had, so we had to count up the sides. So our perimeter is 40. So 1/2, 6 times 40. I'm going to take 6. 40 times 6 to get 240. I want half of that, so divide by 2, and area equals 120 inches squared. Okay, so what you're going to do today and then continuing on Monday is, if you had it in person, it would be a packet. So it's going to be multiple pages of all of the figures that we've seen together so far, or seen throughout the unit so far. So, for example, here's a triangle, but you have the formula right here. So you don't even have to go back to the other lessons and look for those formulas. So we have a triangle, we have a parallelogram. It tells you what each of the figures are, and I put in the formula. And each one has only the information that you need. So the triangle has the base and the height. The parallelogram has the base and the height. Those are just triangles and parallelograms on this page. Here we go. If we look down at the trapezoid, we have the 2 bases and the height for that formula. Same here, except for our 2 bases are here. It's on its side, and there's its height. Those are parallelograms and triangles. And then here we get into some of our regular figures. So we have the 1/2 apothem times perimeter. So maybe because you just watched the lesson on this, you might want to skip to number 16. 16 is where that starts. Skip there first and work on those problems first. Each problem gives you the apothem and a side length. And so I just reminded you that lowercase a is apothem, capital P is perimeter, and off to the side on each one of these, I just remind you to find the perimeter. And remember, we do that by taking the length of the side times the number of sides. So it has a total of 20 problems. So a good way to split that up would be to do 10 today and 10 on Monday. But Monday won't have a separate lesson. You're just going to do this packet today, and then, let's see. Yeah, today, and then it will continue on Monday.